Hello dear students. Now we will go for the next sub bit of the module, fifth. This is hydrographic surveying. Just have a look at the fifth module. This is modern methods of surveying. In modern methods of is your the aerial photogrammetry. Before that we have covered what is the field astronomy. Now we are going to start with the bit 5.6 hydrographic survey. In hydrographic survey we will see what is the introduction of this. Then we in introduction we will see many more things which may not be elaborated here in the US syllabus. Then we will see what are the different organizations which are decided and governed by the international standards and the Bureau of Indian Standards. So without hydrography, you can see the pics here, no ships that could have been sailed. Then without the hydrography, well planned port would not have been possible or built up. Then also without hydrography, you can see a offshore infrastructures also could not have been possible to develop. Then no environmental plan also could have been implemented. Without hydrography also, so you can see the pictures, the adverse impact of this here, here and here. So the impacts of the different environment can be seen in these pics, but with well planned and proper study of hydrography, this can be maintained and can be very well developed. So what is hydrography? Basically the hydro means the water and graphy means the writing. So in hydrography together it is charting of bodies of water such as sea, oceans and lakes. To introduce with what is the hydrography, how we will define it is a branch of surveying which deals with any body of still or running water. This is very important, still and the running water such as lake. So mostly you will find that lake is still water, harbor. Uh, Probably you may not understand what is the harbor, but this is mainly related with the seashore, the stream, that is nothing but the flowing stream which is actually in motion, and river which is also in motion. So it's a science of study of again underwater topography. That means so far we have studied what is the topography of the ground surface. Now the hydrography is related to underwater topography. That means you want to know what is the bed surface below the water at what depth, then whether the vegetation has been developed or not underwater. This is that also you want to know. So many more things that you want to know under topography. Then the mapping features, again after knowing the different depths, just like we determine the different depth on the on ground surface, then we develop the contour plans. Similarly for underwater also, after having determined different water depths, we will develop the maps. We call it a simply topographic map. So with this map we will show you different things: shape of the coastline, then location of possible the obstructions underwater, and what are the different physical the features. There are two different words, the obstructions and the physical features. Obstructions, these abstractions has different characteristics that could be we can say coming with the or changing its shape as the low tide and high tide that times comes, and but the physical features that mostly do not change their features. So there is a big difference between the obstruction and the physical features. Then we also want to know what is the shape of seafloor. Okay, after preparing this maps, the purpose of this is the safe and efficient movement of offshore transportation system. So mainly the water transport system, if you see, there are two basically transportation system. One is called as the inland water system, and second one is the oceanic transportation system. So the oceanic, where mostly the sea and the oceans, and inland, where the river or lake navigation is possible. Why do we require the hydrographic survey? So very first is this is the expansion of offshore engineering and shipping industry. So there are many more things as the expansion and the development of the seashore that takes place. So there is the nearby the geographical area also get developed, and the shipping industry also get boomed up. Now second, locating resources at offshores. So there are many more things. So for the oil industries to get developed, crude oil industry to get developed here. So this is also possible to create the infrastructure for this. Then third, providing supporting materials to offshore, inland and marine structures. So here it means the infrastructure to be developed to attend the industries when it gets developed. Then sea and river navigation for cargo handling is also basically when any seashore get developed. So just like for example the port and the harbor, this is the kind of the development. And after this, there are many more things. The trading of the at the seashores, for example, the port that can be utilized, and the trade marketing can be developed. Then last one is the recreation purposes. This is the indirect benefit of this. To this, what are the objective of this? The first thing is that it is possible to measure of tides for sea coast work. So the different tides, low tide and high tide at different times that will be occurring throughout the year. So it is possible to prepare the chart. What could the tide level is possible to attain the depth of the tide level at the as a low tide or high tide. Then determination of shorelines. We can say the geographical boundaries can be established. Then determination of bed depth. This is a very prime objective of this. We mostly concentrating on how the bed depth can be calculated or determined. There are different the methods to determine the bed depth. Then determination of current velocity. So at the whether it is a the sea or it is a lake or river. So in all the cases, the speed of water, the direction of the water current or flow, we can say, it is possible to determine. So many more things that can be derived from this. Determination of scouring and silting of river or seabed. So scouring is nothing but the it is just like the erosion of the bed that takes place. You must have seen that in summer seasons, the excavation of the river bed that takes place. That means when there is no water absolutely, so that the sand can be utilized for the construction purpose. So how this deposition of sand takes place? So from another part of the river, the excavation along with the excavation, the silt get carried out by the flow and get deposited to some other place. So scouring is nothing but the excavation, and the silting, uh, that is nothing but the deposition. That means the level of water get reduced due to the deposition of the silting of water. Then determination of shoals. Shoals is nothing but the kind of deposition of unconsolidated materials which at the time of the tides, high tide or low tide, when that will consolidate or unconsolidate. It means that will prepare or that will make a mass of the consolidated material at the time of high tide, and when it becomes low tide, then it will be get can say isolated. Now we will see determination of location of light rock buoys. So buoys is nothing but the in fluid mechanics you must have studied. It is a floating material. And where are different floating materials that are light rocks, that we also is possible to determine this. Okay, now after having known this, we will go for the planning of the survey. So what is the planning of survey? It starts with the which type of the survey we have to carry it out. So therefore the preliminary investigation is called the reconnaissance. Then how much area we have to do the survey for this. There are different orders: first order, second order, third order, that we are also going to in the today's lecture, some of the slides. Platforms available. Platforms means which the medium you are using as a transportation system, as a ship, aircraft, or leased vessels. Now what is the vessels? Vessels here is nothing but the ships itself, but just like there is difference between the ship and the vessel, just like if you have a vehicle, vehicle is the general term, so which will be involving from a two-wheeler to a four-wheeler. So it may be a two-wheeler, it may be a three-wheeler, or it may be four-wheeler. So there's similarly vessels is a very small boat to a very large ships. So it involves everything. That is nothing but your vessel. Scope of survey. So scope of the survey, that means how much extent the you want to for a shorter term or for a longer term. That means how frequently you have to carry out this. This is called as a short, weekly, monthly, or yearly. Then limiting factors. Limiting factors, definitely the budget is the prime most. Then political interference. Then geographic and operational. These are the different kinds of the limiting factors. Now controls of hydrographic survey. Just like there are two basic things. If you see the survey starts with the principles of surveying. There are two principles, and next to that is the controls on land surveying. It is a vertical control and horizontal control. Similarly, in hydrographic underground water, there are two terms called the vertical control and horizontal control. So what is the control? Vertical control is, first one is the setting of the benchmarks to check the gauge levels. The gauge levels means the depth of the water levels, and determine the what are the water depth here. Then horizontal control, identify reference mark, we call it the control stations. This take place in a horizontal plane, that is at a water surface level, the near shore, and sometimes in combination with the coast. Determine planimetric position of control points from topographic survey. Then determine planimetric positions of points on seabed. Then series of traversing and triangulations to locate the land and marine. So here we also carried out in horizontal control. If want to determine what is the area of this specific area, that what we have to carry out. So it is, if the area is to be known, definitely we need to carry out the survey using some of the instruments, either linear distance or angular measurement. So we are also going to see the method to be followed is a traverse, what the same exactly you have carried out for the land surveying as a traversing or the triangulation. So traversing and triangulation are the two different approaches uh, to know what is the area to be covered. Now hydrography is applied in different for the different purposes. Number one, safety in navigation. So now there are different techniques which are available to make sure that the navigation, traveling, and the in direction wise also possible with the help of well planned hydrographic planning. Then we'll go for the protection of marine environment. We have seen also just now in the very first 2 to 3 slides. National infrastructure development. Yeah, so just like different coastal areas in our nation that can be connected, and we call it as the interlinking of these coastal areas. We call it the national infrastructure development. Coastal zone management, just like for example, as there is a, for example, Goa, so where uh, that comes under some, so all the different the sea coast, they are coming under some zonal areas, and it is possible to develop. That means it undergoes some kind of the planning. Marine exploration, in marine exploration there are many more things that need to be explored under groundwater, and that could be considered at the property of the nation. Resource exploitation, sorry, minerals and the fishing, these are the things. uh, Here maritime defense and security involvement, disaster management. To know this few, this much information is sufficient exam point of view. We need not go into the instruments required. Which are the instruments required for this? Number one is the buoys or shore signals. So buoys, you can say these are the floating the devices. Some of the part just little get submerged into water, and the remaining which will be um, can say projecting above the water surface. So these are indicating some distances. This will be available in these forms. The sounding equipment, sounding equipments will be as a sounding pole or the lead line. So these are nothing but the sounding poles we are used to measure the depth of water, but there are restricted 5 to 8 meters water depth where is possible only, then we will use the sounding pole. And the lead line also, but it's just like uh, string or rope that will be uh, lowered down into the water surface, and the depth can be measured. So what is this that we're also going to see here? Only the thing is that what happens if the water is deep water. So these things, two things, this and these things are used for the shallow water depth. But what happens if the depth is uh, deep one, that is more than generally 10 meters water is called as a shallow water depth, and more than to that we call as the deep water. So what are the different instruments and the technique used for deep water, that we are also going to see. The instrument for measuring angles, so theodolite and the total sections, both can be used for the angle measuring instrument. So mostly what we have just seen as the instrument, these are used for the traversing or triangulation method. Okay, now see in details methods of data collections. So this is the sounding method. You can see this one, first one is called as the lead line method. What is the lead line method? You can see this one is called as the lead, and here material is the lead, and it is, you can say, having weight. So this is related, this is connected to the just rope, and there is regular intervals, there are some pins which will give the distance. So it is possible, or it may be a graduated one also. So you can see it is this is a small the boat, and from here it is lowered down into the water surface, and this is called as a, due to this lead, therefore this line is also called as the lead line, and this is the calibrated one. As I told you, there are regular markings are there, and you can measure the what is the depth of this. Okay, so graduated rope made of chain connected to the lead, and 5 to 10 kg, this is called as the sinker or lead, which is used for this. Now there is a sounding pole method. So this one is not a rope but a one just like a rod. This is called a sounding pole, but this one is also calibrated. This is used or this rod is made up of seasoned timber and 5 to 10 centimeter diameter, and it is possible to only submerge uh, or drop into water for 5 to 8 meter height. So this depth is also limited. Then a lead shoe of sufficient weight which is connected at bottom somewhere here to keep it vertical, and graduations are marked from bottom upwards. So zero marking is here and it is increasing in the order as you go upwards. One more technique is your wire drag survey. So what is happening? Let us say this is the one position of the one of the boat and on water surface, and this is the another water surface or the boat here. Now it is some kind of the projection, and here is some kind of the projection, and in between here a you can say wire is stretched in between these two. Okay, now at regular you can say intervals fixed distance apart there are some uh, you can say the objects which are suspended and having some weight, so they are lowered down or drop into the water. So both all are having equal length except regulator. So what is happening, that due to this weight this string will remain straight. Now what is happening here, let us say somewhere here it come across some obstruction here. So what is happening, you'll find that the wire which is straight here no longer become a straight one. So what it will become a, so there the wire the okay, see it will form as just like a V shape, right? So it will not be straight because you know that there is a obstruction. So even though as long as this is straight, so this is counterbalanced by its weight. Okay, we can see here this will be countered by its weight, but due to obstruction, okay, the length gets reduced. So what is this remaining length, if you measure here, and that will say that what is the remaining measured here. So obstruction is how much above this sea bed you can easily determine. Now one more is the echo sounders. As you said, see here, if your water depth is more than 10 meters, we call it as a deep water depth. So there are different techniques, sound waves which are passed through the some instrument. So these are called as a fathometer or echo sounders. So earlier it was named as a fathometer, but nowadays it is called as a echo sounder. There are two types of, one is the single beam echo sounder and another is a multi beam echo sounder. So multi beam echo sounder is the short form MBES. In echo sounder single type, what is the principle is that same as the electronic waves which are passed through, if you have already used the total stations or any electronic measuring device for the distance measurement. So principle of electronics is that the electronic waves which are passed through this and reflecting back, how much time is required, half of that actually divided by 2 we can say gives the how much distance it has traveled. So it has the relation between the time and the distance. So if you know what is the velocity of that wave, you easily can determine how long it has traveled. Now here same principle you can use for the single beam. This distance, how much is distance traveled. So this can be calculated by striking to this seabed or any river bed. When it is coming back, you can calculate what is the distance or depth of this water. In this case, now we are instead of horizontal, it's a vertical, so we can calculate what is uh, the depth of water. Now in multi-beam echometer, just like there is not a single sound wave which is passing through this, but we can say, for example, this is the initially the coverage of this single beam. It's a single beam itself, but it is not stationary. It is going like this, just moving like a pendulum, once here and once here. So if I draw like this center line of this, so it will be moving to the left and then again moving to the right, so that it can be covering the area in zigzag manner like this. So therefore it is called as a multi-beam eco standard. Doesn't mean that there are many more the devices used for the or projecting the beam. It is not like this. Just this is a movable, and it is moving like a pendulum, so that more area is covered with some fixed tiltation here. Now next one is the airborne laser hydrography. Very short, the technique which is used called as the lidar. uh, Similarly, the lidar, there is one more technique called as the sonar. So the lidar, light range and distance and range, what is the called as a lidar. Similarly, the sonar is that both things we are going to say learn this separately. So what is the principle of lidar is that you can see there when the aircraft is moving, then it emits some of the sound, or you can say waves. These waves, some of the waves, they will be striking to the water surface and again going back, and some of the waves, they will be going water surface, they penetrating into the water, and after reaching the surface of the seabed or river bed and going back here, just to show because there is no actually difference in between here, but to just sake of understanding, going in one direction and again coming back here. So that's how you can calculate the depth of water. So knowing with this, what is on an average altitude, at what height the aircraft is moving. Now what are the different standards for data acquisitions? This is the very most important thing. You will find that there are two is the standards which are followed. One called as the international standard, and the second one is the country specific standard. So Bureau of but that means that all the countries will be uh, the following their own specific standards as well as the international standards. So for our country, we call it the Bureau of Indian Standards. So international standards is the IHO, International Hydrographic Organization. This is established uh, in 1921 and is governed by the International Hydrographic Bureau. Bureau is nothing but kind of the body which is governing all these things. Now, as far as the Indian country is considered, we are following IS code 4650 and we are using the BIS. Now what is the BIS that we are also going to see after this. One more is that in country specific standard, one is the Canadian Hydrographic Service. So this is for the Canadian country. IHO standards. Now we'll see in detail what is the IHO standard. The classification based on area's importance. So what are the IHO standard? First thing is the area's importance for the safety of survey navigation. Now this standard, first of all, we call as the order of special order, order 1, order 2 and order 3. Now to start with, I will start with the order 3. Water depth greater than 200 meters, we call as the order 2. The orders which order 3, order 2 is the depth less than 200 meters, but not previous with the categories. There is no as such categories. Order 1, depth less than 100 meters, they are less hazardous bottom, more clearance, harbors and general intercoastal and inland navigation channels. So order 1 is there where this kind of the activity that takes place. Now special order is, this is minimum under keel clearance. What is the meaning of the keel clearance? Keel clearance means suppose there is a bed of the river bed or sea water, whatever it is. Now the ships, mostly these are the very large ships. Now there is a water level somewhere. So how much is portion is submerged here of the area which is submerged into the water, because different ships or different vessels have different portions which are submerged into water. So irrespective of the all the kinds of the vessels, the minimum clearance or height which is to be maintained between the surface bed surface and the bottom portion of the vessel is called as the minimum keel clearance. Okay, so this is the minimum clear, uh, we call it as a, therefore is called as a special order. So irrespective of this kind of the vessel or type of the vessel, we maintain this minimum keel clearance. Then potentially hazardous bottom clearance, there are some kind of the permanent the obstructions which may come across, that has to be also identified. Closely spaced survey lines, what is the meaning of closely survey? So let us say this is a seashore here, you can see it from the top view, and towards this is your sea water. Okay, now the survey to be carried out, if the ship is moving like this in this direction, so at particular points you can say at regular distance, remember we are seeing from the top, this is everywhere, here is the water surface everywhere and beyond also. So we can say, then again it is coming like this and going like this, and this is like this, it will carry out the survey like this. So this distance and this distance, so how closely spaced, these are the survey points and the survey lines. Then second most important, 100% bottom search. So anyhow whatever the area is to be covered is that has to be 100% to be covered, the only thing is that, so therefore it's called a special order. Okay, so line spacing is a special order if it is 100% bottom search is essential here in this case. Order 1, 3 times average depth or 25 meters whichever is greater. Order 2, 3 to 4 times of average water depth or 200 meter whichever is greater, and order 3 is the 4 times water depth, just to remember here. Now we will see the Bureau of Indian Standard Specification says you the accuracy required for different surveys and desired line spacing for single beam echo sounder survey tracks. Now these standards will follow first in the purpose of the survey. So the purpose of survey, first of all we can say structural installations and dredge quantity estimation. Uh, Dredge means what, how much amount of silt you have to excavate, so that depending upon this also the survey to be carried out, and this comes under your special order, and this all will follow the code IHB SP45. This is the code name, you need not bother about what is the meaning of this. Then purpose of general planning and pipeline route selection, we follow the order to numerical model input purpose order to. Now next, desired line spacing for single beam echo sounder. Again if you are using the single beam echo sounder, again same structural installation and dredge count. Here the recommended line spacing here is a 10 meter. Pipeline route selection and sea outfalls and cables 50 meters, and for this is 100 meter. This one, the drawing you see I try show here in differently. Very first thing is that there are different markings and different colors. First you have to understand this. Now you can see different lines also and some different colors. So this line, all you can see, this one, then this one you can see here, then this one, all that will show the deep water. So what is the water in between all the different lines? This nothing but shows the deep water, and all these the numericals values you can see here, these are called as the depth. The depths are in units. We are not interested or even not bothered about what is the unit of this, whether centimeter, meter, but the thing is that it is some kind of the unit. So 13 is unit, so all over here the unit is same. Now if you see here is a 2, this is a 4. So yeah, as we have seen that 5 to 8 meters we usually call it as a shallow water depth. Now here with some different color, and this is enclosed between this line, you can see this one. This indicates there is a shallow water depth, and there are some shoals, that means unconsolidated some deposit get develop here in this particular region. Now here you can see one more things, the colors, this one red and this one is the green colors, and small circles, and around that there is a small one big color uh, circle with the different colors, and this, so this to indicate as the buoys are nothing but some floating devices which indicate some significance of that. Now um, if you see this one more thing, this is also green, and this one also, this one is also called as the buoys, is a floating, but they are emitting the electric light. So you can see here this one also and this one also. So unlike there is a circle surrounding this, there is no circle. If you see there is no circle around this, so therefore it indicates the red light and green light. So the electronic, I can say, uh, connection is that it is flashing the light, very short is flashing the light. Okay, one more thing which is remaining here is this. So this indicates the lighthouse. So dear friends, that's how we completed today's lecture. So far we have studied the importance of this, the hydrographic survey, what we have seen, the objectives, how it can be useful. More applications we are going to see in the further lecture. Till now what we have studied, just try to repeat the number of the slides, you will understand it more clearly. Thank you very much.